Plastic is not directly related to global warming, but it's one of the strong human activities that leaves a footprint on the Earth system. You find it everywhere, even at the bottom of the ocean and in our brains, as we've talked about before. It's in our body, in our liver, kidneys, arteries, brain, but we don't have a good handle on exactly what it does. But nonetheless, it can't be all good, right? Cannot be harmless, I'm sure. But this is about plastic recycling. We have talked about this before in terms of enzymes or bacteria that naturally eat up plastic. There are bacteria, synthetic bacteria that are used to eat up oil spills and so on, because they are also hydrocarbons. And this article is about a new method that uses supercritical water to melt away plastic. So I wanted to read it just because we want to keep an eye on all the solutions we find that are relevant to overall environmental problems. A worker in Thailand here empties a bag of plastic waste, the production of which is expected to balloon over the coming decades. That's pretty obvious, because even though there is a UN effort going on to limit plastic production, and they will meet later this year, but there hasn't been really any progress in terms of actually signing off a treaty. Plastic is a miracle material, but the way we use it extensively and the way we discard it, it's just a problem, right? So a new answer to the plastic pollution crisis: a world first recycling plant uses supercritical water to turn waste plastics into useful chemicals. So this just appeared in Nature, which I should have put somewhere. I always do this. Anyway, just Google. It's a feature article. Just Google a new answer to the plastics pollution crisis, and you will find it. It just appeared in 2025, February or March. The world is miserable at recycling plastics. We know that currently just 10 to 15% of the plastic waste we generate annually is recycled, with the rest incinerated, buried in landfill, or dumped as litter. And of course, it doesn't disappear at all. A big part of the problem is that much of the waste is a dirty jumble of different plastics contaminated with food, inks, and labels. It's expensive to clean and sort this mess into streams of single polymer or uncontaminated plastic, the kind that is generally needed for conventional mechanical recycling, in which plastics is shredded, melted, and reformed into pellets ready for new products. So if it is all dirty, then you cannot just start making them into pellets. You need clean pellets. That explains the excitement around a chemical plant that will start commercial operations this year in Northeast England, in the US. Northeast England. Northeast is something else. Okay. In principle, it can take any kinds of plastic waste, including mixed plastics deemed unrecyclable, and break it down into chemicals that are similar to those extracted from crude oil. So, basic input to the production process. With further processing, these chemicals can be turned back into fresh plastic. If successful, it could be a powerful example of a circular manufacturing process in which plastic is used and reprocessed over and over again, and potentially curbing the world's dependence in the process on fossil resources to make virgin plastics. Of course, the problem is that it doesn't get rid of the microplastics and nanoplastics necessarily, right? The facility near Redcar uses a variation on a concept called chemical recycling, which breaks plastics apart into smaller chemical building blocks. Its main rival in this approach is pyrolysis, heating plastics to temperatures above 450 degrees C in a reactor without oxygen. But pyrolysis is energy intensive and inefficient, with much of the plastic being turned into useless sooty char, which you have to then deal with. By contrast, the new plant I'm hungry, it's lunchtime. By contrast, the new plant uses water at high temperatures and pressures to break down plastic waste more gently and cleanly. Mura Technology, the London-based company behind the facility, says it is the first commercial-scale plant in the world to recycle plastic in this way. There is a lot riding on its success. If at all it works and runs profitably, it could trigger the launch of many more of these plants around the world. Mura has declared the technology to be revolutionary because it has the potential to help eliminate plastic waste, recycling all types of plastics to create a true circular economy. Mura says that its process has lower carbon dioxide emissions and a higher tolerance for contaminated waste than does pyrolysis. I'm making too many mistakes, sorry about that. It also emits roughly 80% less CO2 than burning the plastic in an incinerator to generate energy, a common way of dealing with waste. Okay, so is this a panacea then? Well, obviously others will have other things to say. As with pyrolysis plants, not all of the facilities products of Mura will be reborn as plastic. Some critics say that the process shouldn't count as recycling, an accusation that Mura rejects. So you know that immediately there are going to be problems, but the idea is not a dud, but the real life complications around the process make it less revolutionary than claimed. What is the plastic world we are living in then? Plastics pollution is a serious and growing problem. Recycling technologies already struggle to cope with today's waste, and the Organization of Economic Cooperation and Development, OECD, expects plastic waste production to balloon to more than 1 billion tons per year by 2060. We are, I think, at around 400 million tons now. Mechanically, recycling is the most common recycling route, although the process often yields material that is a little weaker than virgin plastic. It works well enough for pure streams of some plastics, such as the polyethylene terephthalate PET, which is common in drinks bottles. But the other forms of, the plastic that carry drinks, or even the one you carry water in, shouldn't leach plastic. It should be reusable if it's a water bottle that you carry for hiking and keep for years, right? But other forms of plastic waste are much more challenging. Take flexible packaging and films, for example, a category that includes detritus such as grocery bags, bubble wrap, and snack wrappers. These are typically made from various forms of polyethylene and polypropylene, part of a broad class of polymers called polyolefins, which make up 2/3 of all post-consumer plastic waste. Okay, so on the face of it, it's quite promising. I think that there is a lot of excitement that's about the new supercritical water-based gentle melting away of plastics to recycle them. So is this going to work? The surging enthusiasm for chemical recycling, there is a explanation for that. Many researchers, companies, and policymakers think that this approach could extract more value from the tricky plastic waste and thus provide an incentive for recycling, because a lot of times, you put recycled material or recycled material by separating them in trash, and you read that they are just dumped somewhere or mixed together and so on and so forth. So the recycling business doesn't have a high level of trust in general. The current most used chemical recycling methods, according to data from the market intelligence company ID TechX in Cambridge, UK, involve unpicking a plastic's polymer chains to recover the constituent chemical building blocks and or monomers. This can be done with solvents or enzymes. ID Tech's terms the general approach depolymerization. However, these are extensive processes that have been commercialized for only a handful of plastics that have already been separated from other plastic waste. So somebody has done some preliminary work to make it possible. By the end of this year, ID Tech expects depolymerization to be overtaken by pyrolysis, a blunter method, energy intensive and polluting. Pyrolysis does not break plastic down into its monomers. Instead, it produces a soup of hydrocarbons called pyrolysis oil, similar to crude oil. Some components of this oil then go through more petrochemical processes to generate specific plastic feedstock chemicals such as ethene and propene, the most common monomers or polyphenols. So a long process. There are roughly 50 pyrolysis plants around the world, most in the European Union and the United States, with combined processing capacity of about 266,000 tons per year, according to ID Techs. That's a tiny fraction of the plastic waste, obviously. However, many more pyrolysis plants are expected to come online by the end of this year, and in developing countries and underdeveloped countries, plastic is just strewn around or burned or recycled in an informal way, where trash collectors collect those and sell in some economy that exists. But pyrolysis has a number of problems. First, some of the oil it produces is turned into fuel or other chemicals rather than going to make new plastic, so it's not recycling, and that portion doesn't help to reduce the amount of new plastics produced. You want recycling so that you don't produce much new plastic, but if you burn it, pyrolyze it, and take it as fuel somewhere else, then obviously you are producing more plastics to replace it. Critics such as the Brussels-based company Group Zero, Brussels-based company I should eat. Sorry about this. Critics such as the Brussels-based campaign group Zero Waste Europe says that the approach should therefore be termed chemical recovery rather than true chemical recycling of plastic. So there are some details that you can find online on this. I won't read all of these. Pyrolysis is also inefficient, and despite the reputation for being able to feed on many kinds of mixed plastics in practice, pyrolysis plants take in polythene plastic waste and relatively clean waste at that. So it's not, it still needs a lot of pre-processing in that sense, unlike the supercritical water, which is able to eat up everything. Chemical recycling, but better, that's where Mura's technology comes in. The method is known as hydrothermal liquefaction, but the secret sauce inside Mura's stainless steel reactor is not merely hot water. The process operates at more than 400 degrees centigrade and 220 atmospheres of pressure, which means that the water is in a supercritical state. It can behave like both liquid and a gas, that's the definition, dissolving oily polymer molecules and chopping them into pieces. On the face of it, it's quite promising. I think that there is a lot of excitement. I've been to quite a few conferences where everyone is talking about, says Kennedy. So here is the plastic waste process. The OECD estimates that less than 10% of plastic waste is currently recycled, and that rising plastic production will lead to a tripling of annual waste by 2060. So if you don't curb new production, you are going to deal with this for a long time. So here is what is going into landfill, mismanaged, so littered or burned in pits, and incinerated in an official manner, and recycled. So you can see recycling in 2019 was hardly 10%. It's at 9%, in fact. A lot of it went into landfill, some of course mismanaged, and then some incinerated and a tiny fraction recycled. Landfills are going to take more by 2060, much more, 500 million tons, and then you'll still have mismanagement and incineration, and OECD expects that by 2060 we'll only be up at 17% of plastic waste being recycled, which sounds quite depressing, right? How to recycle plastics with superheated water then? Mura Technology says that its factory will break down unrecyclable plastics into useful chemicals that can be turned into fuels or fresh plastic, so you will replace some new production. Here is waste plastic coming in. It's shredded, and then non-plastic stuff is removed. Plastic is melted and pressurized, and the extruder takes it into this plastic molecules, so hydro-PRT, where the plastic molecules are broken down. So that is a plastic recycling technology, PRT. It's patented, I'm sure. More than 400 degrees centigrade and 220 atmospheres of pressure. Water in the reactor is supercritical. Light hydrocarbon gases from the plant, about 10 to 15% of total output, help to heat this water. So the pressure is released in this process to maintain the continuity of operation. Flash distillation into petrochemical products, so heavy residual oil, heavy gas oil, distillate gas oil, and naphtha. Okay, and there are various percentages here. What are the environmental questions? Is all this good for the environment? That's a key question, right? There's the recycling, life cycle analysis part, where you have to make sure you are not using so much more energy that this doesn't add up to much of a value, but you also want to see what net impact will be there on the environment. Stuart Coles, a sustainability researcher in the Warwick Manufacturing Group at the University of Warwick, UK, has carried out an independent life cycle analysis of Mura's process in a study funded by the UK. It found that hydro-PRT emitted a little under half a ton of CO2 per ton of waste plastic. Much of that comes from the electricity used for separating and sorting the plastic waste, along with some electrical heating, so the emissions should decline as the UK electricity grid gets greener. Okay, so optimistic. Finally, what are the issues with rules and regulations? I have briefly summarized it here. There's a lot of text I have jumped over. Regulation and controversies. The driver that's spurring investment in all chemical recycling processes, including pyrolysis and Mura's hydro-PRT process, is really regulation, says Kennedy. An EU directive stipulates that all types of plastic bottles should have 30% recycled content by 2030, for instance. Another broader regulation will require contact sensitive packaging, such as plastic container for food and cosmetics, to contain 10% recycled material from 2030 on, potentially rising to 25% by 2040, and so on. The United Kingdom too has brought in a tax that penalizes plastics packaging with less than 30% recycled content. So then you get into the idea of recycling, who's verifying the labels, etc. Labeling, and who's verifying the labels, etc. Minimum recycled content targets for packaging will drive demand for chemical recycling, because very few plastics can be mechanically recycled to a high enough quality, says Uti Teras, who leads technology commercialization of chemical recycling at Nestle. Okay, well, was it useful? I think I am excited about people still thinking of doing plastic recycling in a careful way and not just use pyrolysis till something else comes along, or not invest in new technologies, because pyrolysis will keep going, and that doesn't reduce new production, that doesn't reduce filling up landfills, that doesn't reduce expanding landfill use and expanding mismanagement, and so on and so forth. So as I said, this is not directly global warming, but eventually you will find that this is part of the overall human anthropogenic activities that we have to worry about. We are worrying about it, and again, remember that this is not talking about microplastic, nanoplastic issue, but just talking about macroplastic recycling, chemical recycling, as opposed to pyrolysis. Okay, let's leave it here.